Okay, this video is all about chemical bonding. The reason that atoms bond with each other is so that they can feel stable. Remember, they want to be like noble gases. They want to have 8 valence electrons. There's 2 different ways that they can do that. The first is they can either fill their valence shell by gaining electrons. The other way that they can do it is by getting rid of all of the electrons that they have in their valence shell so that the next energy level down becomes their valence shell. So when that happens, they form a compound. And that's just a substance that's formed when 2 or more elements chemically combine. And remember, anytime you have elements that are chemically combining, you have a chemical change and new substances that are forming. Alright, so before we talk about the types of bonds that occur, let's talk about something called a Lewis dot diagram. And a Lewis dot diagram is just a way that you can show how many valence electrons an element has. So the way that we do that is we show the element symbol surrounded by dots, and each dot represents 1 valence electron. So for instance, lithium has 1 valence electron, so it would be Li with 1 dot. Nitrogen would be N with 5 dots. And generally we do it so that they kind of pair up, so that there's 4 sets of 2. And then neon would be Ne with 8 valence electrons, since neon is a noble gas. You can also use Lewis dot diagrams to represent ions. Remember, ions are atoms that have either gained or lost electrons, so they have a charge. So if we were going to do a sodium atom, the sodium atom would look like this. Na with 1 dot, because sodium has 1 valence electron. And that sodium atom would have 11 protons, which are positively charged, 11 electrons, which are negatively charged, so it would have no charge at all. That's a neutral atom. But when it loses its valence electron, it's going to become an ion. So it will have 11 protons, because that can't change, 10 electrons, because it lost that 1 valence electron, so it has a charge of +1. Scientists always write it with the plus afterwards, though. So it would be Na with a plus next to it. We don't show the 8 electrons when it's an ion like that. We just put the plus. For fluorine, it would be a little bit different. So for fluorine has 7 valence electrons naturally. So there are 7 dots here for that. It has 9 protons, 9 total electrons. So it has a charge. It has no charge. That's the neutral atom. It's going to gain 1 electron to get to 8 valence electrons. The way that we showed that is with 8 dots around it and a minus next to that. So it would have 9 protons still, 10 electrons, so that would have a charge of -1 because there's an extra negative charge. Alright, so there's 2 types of bonds that occur. The first one is called an ionic bond. And this is when one atom transfers at least 1 electron to another atom. So it gives it up and it no longer has that electron. This happens when you have a metal reacting with a nonmetal. And when this happens, the number of electrons that are lost must equal the number of electrons that are gained. So the overall compound that's formed can't have a charge. It's got to be neutral. And when this happens, it's basically the bond that's formed is really just a really strong attraction between that positive ion and the negative ions that are formed. And that's the bond. So ionic compounds have specific properties that almost all of them have. One is that they're very good conductors of electricity, but the only way to find out is to dissolve it in water. Another one is that they all have high melting points. And then the last one is that they are generally solids at room temperature. The second type of bond is called a covalent bond. And covalent, co means together. So what that means is that there are electrons that are shared between 2 atoms. So the atoms don't actually give up their electrons. They share them between each other, so they have them together, where the co comes from. So when this happens, this occurs when you have 2 or more nonmetals. So it's only nonmetals that are involved in covalent bonds. You can't have metals involved. And when this happens, you form a molecule, and that's just an individual group of covalently bonded atoms. So like a water molecule is 2 hydrogen atoms and 1 oxygen atom. And that would be one single molecule or one single group of atoms that form a water molecule. And the properties of covalent compounds are completely opposite from the ionic compounds. So they are very poor conductors of electricity. They have very low melting points, and most of them are either liquids or solids at room temperature. If they are, or liquids or gases at room temperature. If they are solids, then they're more like they're kind of like plastic. They're not super hard.